This is Dr. Jim Logan. My good friend and colleague Dan Adamo and I have been developing a suite of design reference missions that would culminate in the first extended human exploration of the Mars system. For a variety of reasons that we will discuss in this and in future posts, the outer Martian moon Deimos appears to be the best candidate destination for achieving the first human toehold.
Although there are many challenges to successful human exploration in interplanetary space, the two biggest are flight dynamics, always constrained by the cold hard physics of the rocket equation, and bioastronautics, the psychophysiological realities of human adaptation, or lack thereof, to the deep space environment.
Dan is the perfect collaborative partner for me. He's a flight dynamics professional with 22 years of experience in the Mission Operations Directorate at NASA's Johnson Space Center. He supported 60 shuttle flights as FIDO, our acronym for Flight Dynamics Officer in NASA's Mission Control Center. Recently retired, he's now an independent astrodynamics consultant here in Houston, Texas.
Jim is a medical doctor, board certified in aerospace medicine, with 19 years experience as a NASA flight surgeon. He has held numerous positions at Johnson Space Center, including Chief of Flight Medicine and Chief of Medical Operations. A recipient of NASA's Distinguished Speakers Award, he is a founding board member of the American Telemedicine Association and co-founder of Space Medicine Associates. As you can imagine, this former FIDO has learned a lot from Jim in his retirement.
What you are about to see is a high-fidelity trajectory design of Mars Approach and Deimos Rendezvous created by Dan and rendered using Celestia, an open-source 3D space simulator. This video portrays the tail end of an 8-month journey from Earth departure to the Mars system. This is exactly how it would look to our crew of 3 as they approach Mars on July 26, 2012.
The reason we chose the 2011-2012 launch season is it's a worst-case scenario in many ways. Mars is near aphelion, its farthest point from the Sun, so a round trip is of nearly maximum duration and propulsive expense. As we begin the simulation script, we first rendezvous with our spacecraft during its terminal approach to Mars.
The script enables labels, so we can see Phobos and Deimos in orbit around Mars and other planets as well. Our Mars Transfer Vehicle spacecraft wouldn't look like this, but that's a subject for a future post.
In order to compress this video's duration, we are moving about 2,000 times real time now. Those of you who are familiar with Martian topography will recognize Olympus Mons, the tallest known mountain in the solar system, and the Tharsis volcanoes. Then we will slow to 250 times real time around the night side of Mars so that we can see sunset immediately after breaking into Mars orbit. We will be in the shadow of Mars for about an hour. Earth is hidden behind Mars for about 40 minutes during this time.
Next is sunrise. Note the position of Jupiter, the Sun, Mercury, Venus, Earth, and Uranus at the far right. If you look quickly, you can even make out the Pleiades between the Sun and the eastern limb of Mars.
Then we pan around for a few seconds in real time to find Deimos. Once it's centered, we speed up to 1,000 times real time and watch Deimos get rapidly bigger. After capture into Mars orbit with a speed change of 1.657 kilometers per second at an altitude of 380 kilometers, we're in a Hohmann transfer ellipse whose apoapsis, or high point, nearly intercepts Deimos.
This all happens in less than a day in real time. As we close in rapidly on Deimos, we slow down to 100 times real time, then to just 10 times real time, or you wouldn't see much. As you can see, Deimos is starting to pass us by because we're only traveling half as fast as Deimos right now.
After a small speed increase of 680 meters per second, we come to a graceful stop in Deimos' orbit, trailing the moon several kilometers away. This is some of the best imagery we have of Deimos. Rather than end the simulation at this point, we decided to back off and do a fly around to track Deimos at 3,600 times real time as it orbits Mars, so you can get an appreciation of the actual shape of Deimos. You'll see Mars and Phobos go by in the background. We are fixed on the stars as we slowly orbit Deimos here. The Deimos is a full 12 kilometers across, much bigger than near-Earth asteroids we are considering visiting in the near term. Note how Deimos always keeps the same side facing Mars. This makes it easy to observe and communicate with points of interest on the Martian surface from any point on the Mars-facing hemisphere of Deimos.
As we get through with that revolution at 3,600 times real time, we're going to zoom into the surface of Deimos and turn our gaze toward Mars at 10,000 times real time. This is the view our crew of 3 would have from a radiation-protected subsurface Deimos habitat.
Note that from Deimos, Mars appears to slowly rotate eastward at only 2.7 degrees per hour. A Mars surface feature undergoes 2 sunrises and 2 sunsets as it remains continuously visible from Deimos. Notice the sun missed Mars at local midnight, placing Deimos in continuous sunlight at this season. If you were on Deimos near its equator, you would see the sun rise and set each sol, but solar arrays on opposite sides of Deimos would supply you with continuous power except near Martian equinoxes. We've almost done a full circuit of Mars. If you had several Mars surface assets positioned at regularly spaced longitudes, you could circulate westward from one to the next and explore 24/7. Over a period of 5 days, 11.2 hours, nearly the entire planet is seen.
Although an eventual human landing on Mars is inevitable, we believe orbiting humans in the loop, controlling telerobotic exploration of the Martian surface is the way to begin. Only 20,000 kilometers away from Mars itself, Deimos is less than 5% the distance from the Earth to the Moon. This means the round-trip light time, very important for line-of-sight telerobotics, is only a little over 1/10 of a second, 20 times less than the round-trip light time from the Earth to the Moon.
In fact, there isn't a single objective in NASA's Mars Design Reference Mission Architecture version 5 that couldn't be accomplished with this telerobotic exploration concept.
One thing for sure, the view will be spectacular. As seen from the surface of Deimos, Mars would appear 1,000 times larger and 400 times brighter than the full moon is seen from Earth, and it would take up 1/11th the width of the entire celestial hemisphere.
Before I created this simulation, Deimos was a completely foreign place to me. Now it feels like a second home. We hope you agree.